All right, welcome to lecture 17. This is part B, and in part B, we're going to look at our final kind of reaction. Those are called acid-base reactions. So let's go ahead and get into it. Okay, so we're on to our last kind of reaction. So our last kind of reaction is called an acid-base reaction. Now you could probably guess what's going to be reacting here, right? An acid and a base. So the other thing I want to tell you about these, though, is sometimes besides being called an acid-base reaction, they're called a neutralization reaction. So a neutralization reaction, same thing. Same thing as an acid-base reaction. All right, so we're going to be reacting an acid with a base. The other thing I can tell you about this reaction is it's going to seem kind of similar to those precipitation reactions that you've been learning about, as far as it's still a double replacement reaction. So we're going to get that switcheroo thing going on. Positive of the first goes with the negative of the second. The negative of the first goes with the positive of the second. So we still have that double switch going on. Now, the only other thing that makes this a little different, I should say, than a precipitation reaction is that we're going to be creating water in these reactions. So these reactions don't typically make a solid. They're not making a precipitate. What they're doing is creating water. So making water is actually really good because water is a very stable molecule. And so nature likes to create stable molecules. And sometimes those stable molecules are solids. That was precipitation. Sometimes the stable molecule we create is water. And that's going to be in an acid-base reaction. So let's take a look at one. All right, let me put up an acid-base reaction. Let's switch colors here maybe. HCl plus NaOH. All right. All right, so we're going to write out this reaction. We're going to try to figure out what we made in a minute. Before we do that, let me ask you a little question. We're reacting an acid and a base. So look at those two formulas. Which one is the acid? Oh, I hope you know it was the HCl, right? So HCl is the acid. How do I know that it's an acid? Because it starts with H. All right. Now, the other thing I'll mention is that the NaOH, that's a base. Now, how do I know that? The way that I know that is it turns out this OH right here, that was a polyatomic, and the name of it was hydroxide. And it turns out we find in most bases, and there can be some exceptions to this, bases usually, I'm going to say usually, contain hydroxide, usually contain OH. All right. All right. So if you see a molecule that starts with H, that's an acid. And if you see a thing that's ending with OH, that has OH in it, that's hydroxide. In other words, that's a base. All right. So let's go ahead and figure out what we're going to make. And gosh, I probably need a little more room. Let me just rewrite this reaction real quick. I'll put it down here. And we're going to still have to do that double switcheroo business. Okay. So a lot of it's similar to precipitation. So first thing we did when we wanted to write out a precipitation reaction, I told you, figure out the charges on everything. All right, hydrogen, plus one kind of fella. Chloride, minus one kind of fella. Sodium, plus one kind of fella. And then OH, well, it's not on the periodic table, right? It's a polyatomic, but if you looked it up, you would see OH is hydroxide is minus one. Okay. All right. So we know our charges. Just like precipitation reactions. Next thing, switcheroo. Positive of the first goes off with the negative of the second. That's your outer guys. And then your middle guys get together. All right. So the products, and we'll have to figure them out perfectly in a minute, but basically we're going to be putting hydrogen with hydroxide, my outers. And then I'm going to put my inners together. Now remember, when we write a formula, always put the positive thing first. So it is going to be Cl with Na. Now, we always want to write the positive thing first, so it's really going to be Na and Cl together. All right, now, I should tell you, I made this one, I hope, not too bad. And one way that this is not too bad is if you look at both of these things, the charges already sort of even out. So yeah, we still need to also figure out some new subscripts potentially, but in this one, it's not too bad, right? Hydrogen is +1, hydroxide is -1. They're just going to be getting together. Don't need any extra subscripts. And sodium is +1, chloride's -1. They're going to be getting together. 1 and 1, don't need any extra subscripts. So my other product would just be NaCl. All right. All right, so that's what we're making. Now, other thing I wanted to mention about this is look at the formula of something I wrote there. HOH. HOH, that's really the same thing as H2O. It's the same exact atoms gotten together. So sometimes, and actually in this section, I'm going to be writing water often as HOH. Why on earth would I do that? Why not write H2O? Well, the reason why you might want to think of water as HOH is because it's going to help you kind of see who's getting together. The hydrogen from the acid, the hydroxide from the base, the OH from the base. So that's making HOH or water. All right, so one last thing I want to tell you, or I should do on this one is, again, it got a little messy. Let me just kind of rewrite it on this screen, and then we'll move on to another example. So let me erase this a little bit. So this first example would be, we're taking hydrochloric acid, that's HCl. It reacts with sodium hydroxide. We make water, which we could write HOH, or if you want, write H2O, same thing. And then we also make sodium chloride. That would be an example of an acid-base reaction. Again, I made it pretty straightforward, I hope. We didn't need any new subscripts. And also, we could check the balancing. The number of atoms on both sides match up. So we're all set with this one. We don't need any coefficients either, it turns out. All right, so let's try another one. Let's try another one that's slightly more complicated. Let's make it a little bit tougher. All right, let me flip to the next screen and we'll do another one. All right, let's try one a little tougher, huh? All right, so why is this one going to be a little tougher? Mainly just because the charges aren't so nice and even. So we're going to probably have to do a little more work on this one with like subscripts and balancing, but it's still going to be the same idea. We got ourselves an acid. How on earth do I know it's an acid? Starts with H. It's reacting with a base. How on earth do I know that's a base? It ends in OH. So we have an acid-base reaction going on. So the way we're going to figure out what we made, first thing we're going to do is know our charges, because the charges help you figure out what you're making, the formulas of what you're making, right? So we got hydrogen. Hydrogen is +1. All right, that's its charge. And then you get to PO4. Now PO4, that's actually a polyatomic, and really, gosh, on this tiny screen, I can't put up the polyatomic list, but it's on there, I promise. PO4 is called phosphate. It has a -3 charge, all right? So the PO4 is hydrogen, we already said was +1, and the PO4, that polyatomic, is -3. All right, let's keep on going down the list. Now, the next thing I run into is K. So K, the charge on potassium, again, he's in the +1 column. And then we get to our other polyatomic, the one you're going to always see in acid-base reactions, because bases always contain this fella, OH. OH is hydroxide, and it's got a -1 charge. All right, so we know all our charges. Now we're ready to figure out what the heck we're making. Switcheroo time. Positive with the negative. Hydrogen and hydroxide go together. Hydrogen and hydroxide go together. H and OH. All right. And then you put your middle guys together. Now remember, when you start thinking about the formula, we always got to put the positive thing first. So K is getting together with PO4, phosphate. Those are my products. Now, yeah, we still got to remember the subscripts and all that. Now, let's figure out those subscripts in just a minute, because I think we're going to have to do a little balancing of charges. Like I said, this one's a little tougher. But the other thing I wanted to mention, just so you don't get confused, and you know, I hope you think about this question. When you look at what I'm putting together on the right-hand side, this 4, I kind of just took over, right? I'm still there. But this 3, I didn't write that 3 right there. So what's the difference? Why did the 4 go over to the other side, but not the 3? Well, the difference is the 4 is part of what makes this thing phosphate. So if it's a subscript that has to do with the polyatomic list, you see it on the polyatomic list, that carries over. That's why I left the 4. That's why the 4 is still there. The 3 had to do with balancing charges. I'm not bringing that over. The subscripts that have to do with getting the same amount of positive and negatives, we have to refigure those out. And that's what we're going to do right now. All right, so that's the difference. Okay, so let's go ahead and figure out my new formulas. All right, so H and OH get together. Oh my God, H and OH plus 1 minus 1? What's that going to be? HOH. Now that should look pretty good to you, right? Because I told you a minute ago, whenever you do an acid-base reaction, you're going to make water. One of the products has to be HOH, or you can write H2O. All right. Now there is a second product, K, potassium that is, with phosphate, PO4. What the heck is the formula for that going to be? I'm going to let you think about this one. Oh, I hope you know the formula for this. You need 3 potassiums, K3PO4. All right, that's the right formula. All right, so let's go ahead. Now we got all our formulas right. So it's a lot like those precipitation reactions. After you get the formulas right, your last step is to get the same number of atoms on both sides. So we're going to have to add in some coefficients now. So formulas come from charges. Once you get the formulas right, now you're ready to put in coefficients. So let's go ahead and do that. All right, so I think, we've been doing this a little while. Let's go through it a little faster. Give me the same number of atoms on both sides, please. All right, where do you want to start? Doesn't matter to me. Let's start with hydrogen. There are 3 hydrogens on the left. Now that's this hydrogen right here, but now there's only 1. So to balance H, I'm going to put a 3 here. So now hydrogen is balanced. 3 on the left, and then 3 times 1, 3 on the right. All right, let's look at the next thing. Phosphate. Phosphate, 1 on the left, 1 on the right. Good. All right, let's go on down the line. Potassium. 1 potassium on the left, 3 on the right. We got to still fix potassium, don't we? We need to fix potassium. We need to put a, I guess we'll need a 3 right here, wouldn't we? We'll put a 3 right here. Now we have 3 potassiums on the left, just like there are 3 on the right. And now what else did that 3 change? It also gave me 3 OHs. And on the right, there's 3 OHs. What? How are there 3 OHs? Oh yeah, there's 3 right here. So there's 3 OHs. So that should be balanced, okay? All right, let's try one more. One last one. Hopefully this isn't too bad, right? It's a little complicated because you still got to do all that switcheroo business and know your charges and everything. Okay, let's try one more though. Let's try one more. All right, so this one, we're going to put up one more example. Oh, maybe I'll do it, we'll write it down here. We got room, don't we? CaOH2 plus HI. What are we making? All right, first off, yeah, this is an acid-base reaction, isn't it? The only thing is a little different, right? I wrote the base first. Can you do that? Sure, doesn't matter. So this is the base. It's got OH in it. That's my base. This thing starts with H. That's my acid. All right. So we've got an acid and a base reacting with each other. So let's figure out what the heck we're going to make. All right. So to figure that out, I know there's going to be 2 products. And we'll go through and prove it, but one of the products should be water, right? So let's go ahead and see what we come up with. So we're going to have to figure out our charges again. Calcium, right here, +2. All right, +2. OH, is that hydroxide? -1. Now let's keep on going down the line. Hydrogen, right here, +1. And then we get to iodide. Iodide is right here. Oh, what were these guys again? Oh, they were -1, right? Fluoride, chloride, bromide, iodine. They're -1. All right, so we know all my charges. Switcheroo time. Switcheroo time. All right, who's getting together? Calcium and iodine. Outers, and inners, middle guys. So one product, and we'll figure out the formula exactly in just a minute, is going to be calcium and, what is it, iodine getting together. Yeah, the outer guys. And then the middle guys got to get together. So again, the middle guys, make sure you always list the positive fella first. Hydrogen, this guy, and hydroxide. By the way, don't bring over that parenthesis 2, right? You only bring over subscripts if they're a part of a polyatomic. So those are the pieces getting together. All right, so next thing, now that you know your charges, you got to write your formulas. So, a little practice time, huh? My first product is calcium and iodine getting together. What's the right formula when they get together? Oh, it should be CaI2. We needed to balance those charges, didn't we? All right, my other product is hydrogen and hydroxide getting together. And that, of course, what do you always make? You always make HOH, you always make water. So, you know, that one, if you're writing something different, there's a problem. It should always be water as one of the products. Does it matter if we write it as the first product or the second? No, this time I'm writing it as the second thing we're making. Hey, that's totally fine. So we're also making HOH right here. Okay, with that, let's go ahead and, oh, we got it. All the formulas right. Now it got a little messy on me. Let me just rewrite it real quick, and then let's see where we're at. So now I know I guess that's calcium hydroxide. I reacted with, what would that be, hydroiodic acid. It turned into calcium iodide and good old water. All right, all of those formulas are correct. 2 of them I gave you, the 2 on the right we had to figure out, didn't we? All right, what's the last thing? Once you get the formulas right, you've got to balance it. So balance it means let's get the same number of atoms on both sides. All right, so I don't let you kind of again think about this one. All right, we got to do a little balancing. So let's see here. Maybe we'll get you started. There's a calcium on the left. There's a calcium on the right. Oh, that's good. There are 2 hydroxides on the left. I only see 1 on the right. So what do you need to put right here to balance it? I'll let you figure it out. Oh, you need a 2 there, don't you? So that would give you 2 hydroxides, just like we have on the left. Now that also gave me 2 hydrogens, like 2 of the H's. So to fix that, we need a 2 here. Oh yeah, now we have 2 hydrogens, just like on this side there's 2 hydrogens. And oh, wait a minute, that also gave me 2 iodines. And oh, what? We needed that because we have 2 on the right. So that should be balanced now. So you need a 2 in front of the HI and a 2 in front of the water. All right, so that's the last one I was going to do like this. With that, I think that's all we're going to talk about for acid-base reactions right now. If you're a little mixed up, yeah, we'll cover these more in Zoom. We're going to do some more practice. And there's actually one more thing I want to show you about this, but I think I'll do it during the Zoom session. So that should be good enough to get you started on this topic, I hope. All right, so moving on, we're done with the reactions for the time being. We're going to move on to a totally different topic in the next part of this lecture.